Hi there and welcome to the screencast. Tonight I'm going to be solving some of the problems you may see on the quiz on writing equations and graphing and solving inequalities. In problem 1 here, I'm asked to write the point-slope form of the equation of the line through 2 points. So when I'm asked to have such a problem, I always want to start by finding the slope of the line, and that's going to be I'm going to find that using the slope formula, which is that. So when I substitute in the values for x1, y1 and x2, y2, and oops, I'm a little bit mixed up here, x1, y1, that's better. I get 4 minus negative 4 over -1 minus -3. So that's going to give me a slope of 8 over 2 or 4. Now I'm going to use that slope and one of the points. So let me use the first one. So I'm going to do y minus -4, which is the same thing as y plus 4. And that's equal to 4 times, let's see, x minus -3. Which ends up being x plus 3. So my equation is y plus 4 equals 4 times x plus 3. Alright. The first few words in tonight's secret sentence are the following. It's too bad. Alright. The next one, let's see, this is an absolute value inequality, and it's a greater than case, so I'm always going to solve the greater than case by writing two inequalities that do not have absolute value symbols. And one of them is going to look like that, and the other one is going to look like that. So now let me solve each of them independently of each other. And I get 8k less than -64. Then I'm going to divide by 8. And I get k less than -8. And the other one, I'm going to add 2 to both sides. That gives me 8k greater than 68. Then I'm going to divide by 8. And I'm going to get k is equal to, let's see, 68 over 8 is what? 34 over 4. And that's 17 over 2. So I get k is greater than 17 over 2, and 17 over 2 is 8.5. So now I'm ready to graph those, and one of them, k less than -8, is going to turn into that, and then k greater than 17 halves is that. And I am all set. And that's as far as I can go with that problem. Alright, the next few words are tonight's storm turned out. Alright, and finally I have a system of inequalities that I'm going to solve by graphing. So the first step whenever I'm asked to graph a single inequality is to graph the borderline. So for the first one, the borderline or boundary line is y equals -6x minus 3. That's in slope-intercept form. So I'm going to go down to -3 on the y-axis. That's my b value. And excuse me. Excuse me. And then my slope value is the coefficient of x, which is -6. So the slope of -6 is -6 over 1, which is down 6 to the right 1. So I go to -3 on the y-axis, and I'm going to go down 6 into the right 1. Now since that's off the graph, instead I will go up 6 and to the left 1. 2, 3, 4, 5, 6 over 1. Alright, that's going to be a solid line because of the less than or equal to. So let me draw a solid line connecting those 2 points. Not too bad. And now I need to decide which side to shade. Okay, I'm going to pick a test point. of 0, 0, substitute in the test point, and I get 0 less than or equal to negative 6 times 0 minus 3, which is less than or equal 0 less than or equal to negative 3. That's a false statement. 0 is greater than negative 3. So that means I shade the side that does not contain the test point, which would this be this side. Alright. Okay, then let me graph the other equation, or the other inequality. So its boundary line is going to be y equals negative x plus 2. That's a b-value of 2 and a slope of negative 1. So I'm going to go to 2 on the y-axis. A slope of negative 1 is down 1 and to the right 1 for slope. So let's see, down 1 to the right 1, and then I'm going to connect the dots. This time it's a dotted line because I have less than, not less than or equal to. So let me connect the dots, and I'm going to get something that looks like that. And then I need to decide which side to shade. So let me do a test point of 0, 0. What does that give me? I put 0 in for y and 0 in for x. I get 0 less than negative 0 plus 2, which is 0 less than 2. That's a true statement. So I'm going to shade the side that contains the test point, which in this case would be that side of the line. Alright, and then the solution region is going to be the point where the two intersect, and that is that region in there. Alright, the last few words in tonight's sentence are to be a dud. Alright, I hope someone watched this and get a good night's sleep. We'll see you tomorrow, and cheers.